Okay, now isotropy and anisotropy. These two are the properties of solid. So first thing you should know what type of properties are called isotropy, what is called anisotropy. The substances which have, this is very important, the substances which have the same physical property, which have the same physical property. Physical property means like your conductivity, then mechanical strength, this type of property. Mechanical strength, etc. in all directions. In the space, are called isotropic substances. And the phenomenon is and the property is called isotropy. So what is isotropy? As you know, solid, they have 3D structure, na? So when you study the physical properties like conductivity, refractive index, mechanical strength, if you want to study, suppose this is x direction, this is y, this is z axis. So when you measure these properties, like if you want to measure conductivity, suppose in x direction you measure the conductivity, in y direction you measure the conductivity, in z direction you measure the conductivity. When you get the similar value of conductivity in all directions, then that type of substance are said to be the isotropic substance, and the property is known as isotropy. Normally, amorphous solid, if the solid is amorphous solid are isotropic in nature. So when you measure the physical property in different directions, and if you get similar value in all directions, then that type of your substance are called isotropic substance, and the property is said to be isotropy. But there are some there are some substance which gives different value in different direction, then it is said to be the anisotropic substance. The substances which have different values of the physical properties in different directions are called anisotropic substance. And the property is called anisotropic. Crystalline solids are anisotropic in nature. So this is also one point of difference between crystalline and amorphous solid. Amorphous solids are isotropic in nature. crystalline solids are anisotropic in nature. So those substances uh, in which you will get similar value for the physical property in different directions, then it is called isotropic substances. And if you get different value in different direction, then that type of substances are called anisotropic substances. And it is found that if your solid is amorphous solid, then you will get similar same value of physical property in all directions, and that is why amorphous solids are said to be isotropic in nature. But in case of crystalline solid, when you measure the physical property in different directions, you will get different value. In x direction you will get different value, in y direction you will get different value, and that is why crystalline solids are found to be anisotropic in nature. Now we'll do, as I have told you, mainly we will study about the crystalline solid, not to study about the amorphous one. So now we will do about the classification of crystalline solid. Actually, crystalline solid you can classify into 4 types based on the nature of the particle. As I have told you, the particle inside the solid, they may be atom, they may be molecule, they may be ions, and based on that, whether the particles are atoms, molecules or ions, based on that, and secondly, what type of force of attraction exists between the particles, based on that, you can classify the crystalline solid into 4 types. One is called ionic solid, one is called covalent solid, one is called molecular solid, and one is called metallic solid. So a crystalline solid can be classified into 4 types based on the nature of the particle and based on the nature of the force of attraction in between the particles. Now, suppose there is a solid in which the particles are ions, I mean some positive ions and negative ions are present. So if the particles are ions, then that type of solid is said to be the ionic solid. For example, sodium chloride, you know sodium chloride is a solid, and what are the particles inside sodium chloride? Some sodium ions and chloride ions you will get. So since the particles are ions, and that is why that type of solids are said to be ionic solid. And as you know, between the cation and anion, the force of attraction is called electrostatic force of attraction. So that is why if the solid is ionic solid, the force of attraction between the particle will be electrostatic force of attraction. So based on the particle and based on the force of attraction, you can classify like that. So crystalline solid, one classification ionic solid, the particles are ions and the force of attraction is called electrostatic force of attraction. Secondly, if your particles are atoms, I mean inside the solid the particles are atoms, then it is said to be the covalent solid. And you know, between the atoms what type of force exists? The force exists is called like covalent bonding forces, because atoms produce covalent bond, that type of force exists in covalent solid. So if the particles are atoms, and then the solid is said to be covalent solid, and in covalent solid the force of attraction exists between the particle is covalent bonding force. Example, you know graphite. Graphite is a solid, graphite, diamond graphite, they contain what? Carbon atoms, I mean they are particular atom. So that is why diamond graphite is said to be one example of your covalent solid. Similarly, if the particles are molecules, there are some solid in which the particles are molecules. For example, if you consider ice, ice is a solid. In between ice, what are the particles? What are molecules? So if the particles are molecules inside the solid, then it is said to be the molecular solid. And in between the molecules, what type of force exists? Which are called van der Waals force of attraction. So like dipole force, dipole induced force, that type of force, which are commonly called van der Waals force of attraction. So when the particles inside the solid is molecule, and if the force of attraction is van der Waals force of attraction, then that type of solid is said to be a molecular solid. For example, you can consider solid carbon dioxide. Carbon dioxide normally exists as gas, but you will get solid carbon dioxide also. So in carbon dioxide solid, you will get the CO2 molecules. Since the particles are molecules, That is one example of molecular solid. Ice is one example of molecular solid. Similarly, another example, if the particles are some metal atoms, then it is said to be the metallic solid. And in between the metal atoms, the force of attraction exists, which is called metallic bonding force. So if the particles are metal atoms and if the force is metallic bonding force, then that type of solid is said to be your metallic solid. So a crystalline solid can be classified into ionic, covalent, molecular and metallic solid based on the nature of particles. So if the particles are ions, solid is said to be ionic solid. If the particles are atoms, the solid is said to be covalent solid. If the particles are molecules, the solid is said to be molecular solid. And if the particles are metal ions or metal atoms, then it is one example of metallic solid. So a crystalline solid can be classified into four types: ionic, covalent, molecular solid and the metallic solid. Thank you.